Differentiation is all about gradients. So our next subtopic on differentiation is the first principles. Our first subtopic was limits. Now, first principles has a specific formula. And I quickly want to explain how we get to this formula. You don't have to know this. You don't have to answer a question about this in the exam. I won't ask you how did we get to the formula, but it's necessary to know how we got to the formula. Now, if we look at the straight line, remember we said differentiation is all about gradients. How did we get the gradient of a straight line between 2 points? We first identified the x value of the first point and the x value of the second point. And then we got the y value of the first point and the y value of the second point. And the formula for the gradient of a straight line was the difference between the y values on the difference between the x values. That was for a straight line. What happened at curves, like the exponential function? Also between 2 points, identify the first x value. But now, because it's not a straight line but a curve, we said, okay, let's take h as a distance to the next x value. So the next x value will be x plus h. So all follow? It's h further on down the number line. And to get the y values, we said, let's substitute this x value into the function to get the y. And let's substitute this x value into the function to get the other y. Do you all follow this notation? Right. Then we said we have an average gradient. So we took the distance between the y values over the distance between the x values. And if you simplify the denominator, you will get h. Are you all with me so far? Right. So this actually is the average gradient between 2 points. Or you can also say it's the tempo of change. Now what happens if we don't want the average gradient between 2 points? We want the gradient at one specific point. That means that we have to minimize this distance h so that that point sort of lies on the first one as well. Okay? So we have to make the distance less and less and less and less and less until it gets to near 0. Right. I think it's load shedding. specific point, we need to move the second point further and further and further towards the first point, so the distance of h tends to 0. And that's where the limit comes in. H must tend to 0, and then we say the second y value must minus the first y value over h will give me the first derivative. And this represents the gradient of a curve. So that formula is the derivative of f, or the gradient function, or the change of tempo, or the gradient of a tangent. We'll get to tangents later. Now let's look at an example. They will ask you if you need to use this formula. Determine the derivative or determine the gradient of a certain function by using the first principles. If they say first principles, you must use this formula. Let's look at the first example. Determine the derivative of this function by using the first principles. Now the first thing that you do is you draw a little sideline to the right of your paper. And the second thing that you do is you write your formula. So the first derivative is f accent x equals the limit when h tends to 0 of f of x plus h minus f of x over h. Now we do have a function. And what does this mean? This means that in the place of x in the function, I must write x plus h. So in the sideline, you first write a function, negative 3x plus 4, and then you work out separately what will this simplify to. So f of x plus h will be negative 3. In the place of x, I must write x plus h plus 4. Then we simplify and we get negative 3x minus 3h plus 4. So that is my simplified answer of f of x plus h. Who's not with me at this stage? Good. Now we must substitute these values in here. Am I going to substitute 0 now? No. So this notation must stay there. I'm just going to write it a little bit to the left. The limit when h tends to 0. And then you write your simplified answer of f plus x plus h. And it's this one. Negative 3x minus 3h plus 4. Minus, minus. If you have a minus and I write anything after the minus, you put it in brackets. So, in brackets, now I must write f of x, that value, and it is this one. Negative 3x plus 4, close your bracket, over h. Can I substitute the h now? No, so I have to rewrite your notation. Limit when h tends to 0, I'm going to multiply the minus in. Negative 3x, negative 3h plus 4 plus 3x minus 4 over h. Simplify on the top. Negative 3x plus 3x gives you 0, so these fall away. Plus 4 minus 4 gives you 0, so those fall away. And you're left with, am I going to substitute the h in? No, so the notation stays. Negative 3h over h. Now we can cancel out. And we are left with the limit when h tends to 0 of negative 3. Is there h in my function there? No. So I can just write the answer. There's no h to substitute, so my answer is negative 3. This means that the gradient of that function at a specific point is negative 3.
So you have to put the notation when you substitute.
Only when you substitute in, you lose the notation. I didn't have to substitute because there's no h. If I substitute the h here with a 0, I get undefined. I don't want that. So first cancel out as far as you can. Write down what's left and then you substitute. If there's no h, then the answer is only negative 3. More questions? Our next example. We need to draw our sideline. Okay. In this case, I know that if I substitute x plus h, it will be a long one. So I'm not going to draw a sideline here. I'm going to leave a little space there to do my f x plus h. The first thing that you need to do is you write your formula. Limit when h tends to 0 of f x plus h minus f of x over h. I'm going to need this answer, so let's quickly work out what that is. In the place of every x, I write x plus h. So it's 2x plus h squared minus 3x plus h plus 2. Am I first going to multiply the 2 in, or am I first going to work out the brackets? Brackets. So the 2 stays there. Short way, x squared plus multiply these 2 times 2, 2xh plus h squared. Multiply the minus 3 in, minus 3x minus 3h plus 2, and then multiply the 2 in. 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 2. Are there any like terms? No, so that's my final answer. Now I can substitute these two answers into my formula. The limit when h tends to 0, first I'm going to do x plus h, so it's this long one. 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 2 minus. And now I'm going to write fx. That one. There's a minus, so I put the rest in brackets. 2x squared minus 3x plus 2 over h. Are there any like terms in the numerator? Yes. Oh, we first need to multiply the minus, sorry. Limit when h tends to 0 of 2x squared plus 4xh minus 2h squared minus 3x minus 3h. Ah, you are right. Thank you. Plus 2 minus 2x squared plus 3x minus 2 everything over h. Now the like terms. There's a 2x squared minus 2x squared. That makes 0. There's a minus 3x plus 3x. It makes 0. Plus 2 minus 2 makes 0. So what's left is written down. Am I going to substitute 0 into h? No. So you still need to write the notation. 4xh plus 2h squared minus 3h over h. Can I substitute the h now with a 0? No. What must I do? Factorize. What can I do? Take out an h. H tends to 0. Take out h. It's 4x plus 2h minus 3 over h. And then we can cancel out these two. Write down what's left. Remember, if you have more than one term, it must be in brackets. Can I substitute the h now? Yes. So I lose the notation. 4x plus 2 times 0 minus 3 gives me 4x minus 3. So the gradient of this curve at the specific point will be this. Any questions? Okay. Let's quickly jot down the homework for tomorrow. We did first principles now in our new lesson. We did examples 1 and 2 in class. So your homework is exercise 3, page 9 in your notes, only the first 5 sums. Let's mark yesterday's homework. Be honest, who didn't do all the homework? Did everybody do it? Wonderful. I'm proud of you. Any questions with those two? Okay. If you have something wrong, don't just write across. Write down next to your wrong answer what you did wrong, so that when you study for a test or exam, you know what to do next. Okay, you don't have to do it now. These are still recorded, so you can do the corrections at home. Number C and D. C. When you have two fractions and you minus, it takes you back to grade 4. You have to get the LCM. You can't cancel out over a minus or a plus. So the LCM is 2x plus 2. Multiply the first term with what it doesn't have, and multiply the second term with what it doesn't have, and then you simplify. Now, when you have one term here, you can multiply it with 1 over x, and then you can cancel out to get your answer. More questions? Number E and F. E. D. Must I explain D? E and F. Can I carry on? Exercise 2. A and B. C and D. E and F. Any questions? E. Okay. What I did here is I changed this square root to x to the power of 1 over 2. Do you know how to get to that? Yes. Right. And x is x to the power of 1. But because I have a denominator of 2, I change that 1 to 2 over 2. And then I have a difference of squares on top, which I can factorize into x to the power of half and x to the power of a half, and then these two brackets can cancel out. Nice trick. G and H. Can I carry on?
Change the limit of H.
H.
Mine is where X changes into 2 or 3. Yours is where X changes into negative 3 or 2.
Yeah.
H.
Negative 3 over 2.
Mine is 2 or 3.
I'm not sure what you are.
I exchange and then 2 over 3. Ours is 2 over 3.
Oh. Oh, okay. I think then it differs from the Afrikaans ones. 2 over 3, then you get minus 6 over 3, so it's negative 2, negative 3, negative 5. Nee. Okay, I will have a look at this one. Negative 2 over 3.
2 over 3.
Only 2 over 3. Alright. I will redo that one for you. I and J. Okay, we'll carry on tomorrow. I and J.